Evening. Last day we have discussed about certain properties, like properties of plants and also components, how the plants differ, how plants are different from one another. So basically, to understand the diversity, we have first identify the plants, the components or the parts of the plant, like the shoot system and the root system. Under the shoot system, we just discussed about the flowers, fruits, leaves, and stem. And now, actually, we were discussing about last day. We were discussing about the leaves and the shape of the leaves and how these can be vary from one species to over one variant to another variant. How it can be varied. We just discuss about that. And these flowers and fruits are there only for the flowering plants. So some plants are not flowering. So the flowering plants, we can observe flowers and fruits. But for the non-flowering plants, we will not be able to observe that in the shoot system. But the leaves and stem will be there. And then the taproot and lateral roots, right, in the root system. So we have to discuss about that today. And I have given exercise, and I saw that you have sent me, yes, you sent me that categorization, right? Okay, so here is, yes, this is, you draw this, right? It's okay. So if you can find, and like if you even stick that, that will be okay. Begonia, banana. Okay, I have just given some types, tip types, and then I ask you to write some examples. Acuminate, coffee, show flower, okay. Acute, okay. So is coffee leaf, so I'm not sure whether coffee leaves is acute or acuminate. So maybe I'm confusing with the mango leaves. Coffee leaf, coffee leaf, coffee leaf. Let me show image of that coffee leaf. Ah, yes, yes, yes. That's that shape, ne? Yeah, that's that shape. So I could remember that as it's similar to the mango leaf, but it's not. So this you can see the tip piece. Yes, that's correct. Okay. Anyway, we discussed about the part of leaf, then base, veins, tip, margin, petiole or stalk, and then the lamina or the blade. Blade is the surface with the lamina, or the blade is the surface, and the base is here, which is connected to the stem, and then the veins. So these together we call venation pattern. So actually, in one of my researches in the university, I was doing this, identifying leaves using venation pattern. Venation patterns. So just try to analyze and identify. So different venation patterns. Venation patterns actually how veins so are spreaded. So different leaves will have different venation pattern to get the specimen. So this is actually sometimes this can be used as an art also. You have to dry the leaves and keep it for some time. Then so wash these leaves with some chemicals. There are some alcohols that you can wash it, and you can dry it after that, and you can get this venation pattern, venations highlight, because yeah, you know, when the leaf is decomposition, so finally the venation will be, final part to decompose is the venation, right? So here, decomposed leaf. If you see a decomposed leaf, so ultimately or finally, the venation will be, that is because that is hard, that will decompose slowly. So you can do this, but you have to expedite the process. You need to use some chemicals, otherwise you have to wait until natural decomposition. So that will keep this venation, and that can be used as art. So because veins are hard, right? Veins are hard, that's why it will be there for a long time. Okay, so leaf part is now over. So you know different part, different leaves will have different bases. Here you can see that, and also different tips, and also the different blades. So these are. And the next thing is the leaf arrangement. So not just the leaf shape, leaf tip, leaf base, blade shape, etc. There are some differences in the arrangement of the leaves. So here are some examples. So this is in singular, you know, as Katu Anoda. So this is a sample leaf. And you can see in the here, this is connected alternative side, right? The leaves are connected alternate sides. Alternate sides means, so see this, let me zoom this. You can, it's not opposite, right? It's not opposite. It's not opposite, it's alternate. Alternate means you can see one here, one connection, and the another connection here. Then the right side connection, then the left side connection, then the right side connection, then again the left side connection, then right side connection, then so the center. We can take it as left or center. So this is what the alternative connection is. So sometimes it's not alternate, it's opposite. Opposite means, so parallelly there will be two leaves, left one and right one, left one and right one. Both are branching from the same place. Both are branching from the same place. That is in guava, pear. Guava, you can see this kind of arrangement. So these are various distinguished or specific features to each leaf. And here also this is, so this one is binary. Binary means it has two, but this one is multiple. So you can see it's branching from the same, but right, this is Rukkatana. You can see it's going in a circular way. So I think you can remember the radial symmetricalness that we discussed in the previous chapter. So similar to that, so this is not radially symmetrical. I'm not telling that this is radial symmetrical, but the thing is, this is this is connected to one stem and it's in the wild way, right? And the other one, so this is circular, spiral manner, right? This is connected in the spiral manner. This is in the same place, same node, right? But this is spiral. You can see. So you can't see you can't see this directly, but if you analyze bow, so bow. Yes, I think it's also the spiral manner. So spiral manner means, and even so you can see in beans sometimes. So bean it's not concerned as a tree, but still. It has the binary one, right? Binary ones you can see. Binary division. Now this, you can see how it's branching. It's branching similar to this. Right? Spiral means, so this is, it looks like 3D, the same alternative pattern. But when the stem is there, one from here, another from here, another from the back side, another from here, another from straight, likewise spirally rotating. So that is another arrangement of leaves. So these all are about the arrangements. So this assignment, I think we have, yes, we have done that. No, not that part. Right, complete the given table using the observation. Observe the environment, identify the leaf arrangement as arrangement. So we have done the tip arrangement, not the leaf arrangement. So you are asked to give some examples. This is easier than the last week exercise. This is easy. So please do this as an activity and also send me the WhatsApp message similar to what you have done. So just identify the arrangement of the leaves. Okay, so leaves are very important to any tree. So we have already learned one main task of leaves. So can you tell me what is that? And leaves are green because of this reason. Yes?
Photosynthesis?
Yes, it's photosynthesis. Photosynthesis means leaves, unlike us, so leaves can produce, it can produce its own food. So we are helpless, right? We are helpless because we have to depend, right? We have to depend on the other species, no? Other organisms. But plants, so they are also depending on some other organisms. So because it's like in the world, it's living world, ecosystem, everybody, each and every animal or organism is connected. They are helping each other. So there are harmful and helpful both, right? All these kinds are there. But the thing is, for the food and nutrition, we have to depend on others now. But most of the plants, they don't want. They can produce their own food because there is a color. Right? The green color has come because of, so that is one thing. So one important thing. So because of this color, it can absorb, because of this color, it can absorb sunlight. And inside that it can produce, and it's also absorbing in the respiration process, it's also absorbing air. And not only in the respiration, in the photosynthesis process, it will use carbon dioxide, right, and also sunlight, and it produce carbohydrates inside the plant. Right. So here, transpiration is a process of evaporation of water from plants. So what is that? So we learn about the evaporation. Evaporation means, what is evaporation? So this, I think we learn in grade 6, I guess. So what is evaporation?
Water.
Yes, evaporation.
Water become gas?
Yes, when a liquid become gas, we call that, not just water. When a liquid become gas, we call it evaporating or evaporation. When liquid become gas. Okay. So here, transpiration. So this is called transpiration. So it's like evaporation. It mainly takes through the it mainly takes place through stomata in leaves. So what is stomata? Stomata means, like you can see these caps. So this in between, this is actually internal structure of the leaves, zoom view. So if you need a color image, let's search for color image, and you can see that this is microscopic view. Okay, here, a 3D. Okay. Like to use this, or names are content. Okay, this even show the veins, right? So what is stomata in synchronous? Can you remember this? So this is this is lower side, not normally they are in the upper side. This is lower side of the leaf or the ground side of the leaf. So no need to know the singular word, but anyway, so these are small holes. These are small holes, right? These are small holes in the leaf, so it helps the evaporation process, right? In Sinhala we call Utika කියලා කියනවා. පල්ලෙහා තියෙන මේවා තියෙන්නේ මේ උඩින් නෙවෙයි පල්ලෙහා leaf එකේ. So this is a leaf and this is a zoomed view. And normally the back side of the leaves, you can see this. It helps evaporation. So if you see in the early morning, if you see a leaf, so you will be able to find small water bubbles underneath of the leaf. But you have to check in the morning before it evaporates, right? Otherwise, you will not see when the sunlight comes, it evaporates. Right? Transpiration helps transport water to upper parts of the plants. Actually, when this stomata, when the water is released from stomata, actually so this is like when you suck, or when you suck water from a bottle, this might happen. So due to the continuity of these molecules or these particles, water particles, due to the continuity, there will be a continuous flow of water. Continuous flow of water. I can show you animation, but in the video we will not be able to see that, but I'll show you small animation related to this and you will be able to understand what I'm telling. So because of this, there will be a continuous flow of water from the root system to the shoot system, and through the veins, water will come up. Actually, what will happen in the transpiration process, it transport water to the upper parts of the plants. Right? So this is actually, so let me show this using the animation. I think it's better. Let's see the video.
We just studied that the transportation of food in plants occurs in phloem and its water occurs in xylem. Now, we'll discuss.
So this xylem, phloem, I'll explain what are they. Just see the animation, just get an idea. So we have not discussed everything related to this, but this root system is basically absorbing water, and also it's transporting it through the stem. Just get that idea only.
It's transpiration and the factors affecting it. Plants continuously absorb water from the soil, but not all the water absorbed is used by the plant. Excess water evaporates from aerial parts of plants and mostly through the stomata below the lamina of the leaf. This process is called transpiration. Ever wondered how plants draw water up against the force of gravity? The evaporation of water from leaves results in a suction force.
Here you can see when it evaporates from this stomata, so it causes a suction force. So when you suck water from a straw, so this will happen. So there will be a continuous flow, and it used to, especially, so when you when you suck and stop for a while, you can see it will split, right? So it will come out. So water will come out and it will spill here and there. So that can happen. That is due to this suction force. So due to continuity, so these are H2O, you can see H2O. So molecule view, but we have not yet explained that in detail, but just understand water is H2O, two hydrogens and one oxygen connected to create a water. So actually these are also connected to each other, because you know the nature of water. Water is a liquid. So liquids get the shape of its container. So how it maintains the continuity, because air will not do that. Air will definitely spread. So in the container, it will go here and there into the container. It will not take a definite volume. So instead of that, it will spread. Right? Still, it will spread. So for an example, if you connect two balloons together, or if you connect two containers together, and if one container has a color gas, so it will spread to the second container too, lowering the thickness. But water will not do that. If you merge two containers, water will spread into two containers maybe, but the thing is it will not exceed the volume. The same volume will be there. Right? It will take space from both, but the same volume will be there. So that is the nature. So why water has that feature? Because of this connectivity, the bonds,
which pulls water up the xylem vessels. This suction force is called transpiration pull. It is the main force that pulls water and mineral salts up the plant. This upward movement of substances is called the transpiration stream. Factors affecting the rate of transpiration. Transpiration depends on evaporation. Therefore, factors affecting the rate of evaporation also affect the rate of transpiration. These factors affecting the rate of transpiration are humidity, temperature, strong wind, and light.
Okay, so these are some important factors. So what are affecting this transpiration? Right? So as according to the video and according to your knowledge also, we discuss about evaporation in the lower grades. So when evaporation is high, when the heat is high, evaporation is high when humidity is low, because in the air, when there is less humidity, so there is a higher tendency to evaporate, because the concentration in the air, so amount of evaporated things in the air is low, then there is a higher tendency to evaporate. And so that is what happening in air conditioners. So if you are in air conditioned room, your skin will become dry soon. I think you have experienced that. When you are in air conditioned room, even though it is very cool, your skin will become dry. Your lips, your tongue, you feel dry very soon. Why? What is happening in the air conditioned environment? In air conditioner will absorb these water particles in the air, or it will reduce the humidity. ආර්ද්‍රතාවය එක අඩු කරනවා. So as a result, we will feel thirsty and we will feel dry. Right? So when the humidity is low due to this air conditioned environment, so what will happen? It will absorb water from our skin also. That is why we will become dry when we are in the air conditioner. Air conditioner එකක් දාලා තියෙද්දි humidity එක අඩු වෙනවා, ආර්ද්‍රතාවය අඩු වෙනවා. ආර්ද්‍රතාවය අඩු වෙද්දි when this humidity is low, so there is a higher tendency to evaporate. Therefore, it will absorb gas, it will absorb water in. So you can do this experiment. Put a drop of water in air conditioned environment. After some time, you will realize and you will see that has vanished, or that is evaporated. Just put a drop of water closer to the air conditioner, it will be absorbed. It will be dry after some time. So the reason is evaporation. Therefore, humidity is affecting. And also note that when there are more clouds in the sky, when it is ready to rain, the temperature goes up because of high humidity. When the humidity is high, the temperature will go up. Okay, that is another incident. Anyway, so humidity is affecting this. Amount of sunlight definitely affecting the evaporation rate. Therefore, it's affecting the transpiration too. Because when evaporation is high, this will also become high. And then the temperature, right? Humidity of air, temperature, amount of sunlight, and what else? So this is, yes, the wind. When the environment is windy, there is higher tendency to evaporate, because winds take this evaporated gas away, so evaporated particles away. So the new particles will also join this windy environment and evaporate. So let's see them.
Humidity of air. The intercellular spaces in the leaf are normally saturated with water vapor. If the outside air is dry, water vapor will diffuse more rapidly out of the leaf. That is, the rate of transpiration will increase. Whereas, if the air is damp or humid, evaporation is limited. The more humid the air is, the slower it...
These are watermark. So you can see first one. So in the outside environment, right? It's dry, so less amount of water in the outside environment. So diffusion happens. Diffusion is a property of air, right? I think you learned about diffusion. That is a property of air. It spreads and it fills the environment. That is diffusion, right? It basically fills the environment and it diffuses. And so when diffusion happens, right? When diffusions, like you can say in singular, visaranaya. So these things are moving from the high saturated areas to low saturated areas. Here you have high saturation. So here you have low saturation. So basically it's moving from here to here. අඩු සාන්ද්‍රණයක් තියෙන තැනට වැඩි සාන්ද්‍රණයක් තියෙන තැන ඉඳන් මේවා ගලාගෙන යනවා. That is diffusion. So diffusion happens and that will expedite evaporation.
Water vapor will diffuse more rapidly out of the leaf. That is, the rate of transpiration will increase.
Therefore, the transpiration will increase, right? So that is one thing. I think with the animations and all, you can remember these things, no need to write down. But I'll give the note next day. So today I have already taken some time to display and explain this. So let's finish this and next day I'll give the note about this transpiration. So in Sinhala we call utsvedanaya. But that is not necessary since you are learning in English medium. Just remember that. But if you have learned this word in your classroom or somewhere else, then so that is the same thing as transpiration.
Whereas, if the air is damp or humid, evaporation is limited. The more humid the air is, the slower is the rate of transpiration. Temperature of the air. Assuming all other factors remain constant, a rise in temperature of the surroundings will increase the rate of evaporation, and thus transpiration rate also increases. Strong wind. When the air is still, transpiration makes the air around the leaves moist. The water vapors build up and increase the air humidity. Hence, as we've stated before, reducing the transpiration rate. During a windy day, the moist air around the leaf is blown away, making the air less humid. This increases the rate of transpiration.
So I said this before, right? I said this before, what will happen when windy? So it will transport or it will move the like H2O gas away from the leaf. So what will happen? Ultimately, the humidity will be low. When air is moving, when this water is moved away, or this gas stayed as water, right? So that is moved away from the environment, then there will be less humidity so diffusion will happen. So these terms are very important. Diffusion means going from high concentration to low concentration areas. That is diffusion. That is a property of air, right? Then transpiration is where the water movement. So water is like evaporating, or water is moving out from the leaves. So basically it happens the back side of the lamina.
The stronger wind, the higher the rate of transpiration. However, if the wind is very strong, the stomata may close because the guard cells lose too much water. What would happen if there's a cool, wet wind? Light. Light affects the size of the stomatal opening on the leaf, thus affecting the rate of transpiration. During the night or in the shade, the stomata close and reduce the rate of transpiration.
Okay, this is another thing. This stomata is basically sensitive to the light. When light is present, this stomata will open. So that will increase the evaporation rate or the transpiration rate. So I'm always telling this evaporation rate. Anyway, transpiration rate, right? Evaporation is basically common to any liquid. So, but transpiration is in the plants, right? So these are two things, but always I refer to this same incident. That's why I'm using this evaporation. But in this plant related matters, please use the word transpiration, right? So in the night, during the night time, the stomata will close. And stomata will also close when wind is too high, right? Because otherwise the plant will dry, no? To stop drying, then also the stomata will be reduced, the size. But in the night, during the night time, it will be closed. So it will be reduced. But it's sensitive to the light. When light is present, this will increase the size, and therefore the evaporation again, transpiration will be.
Transpiration. But on a sunny day, the stomata open wide and increase the rate. The movement of water vapor outward also removes heat from the plants, thereby cooling the leaves and preventing them from being scorched by the hot sun.
Okay, so that is the idea about transpiration. There is another 3D one also. I'm not sure. This is a bit old, right? This is a bit old.
The roots of plants absorb water and mineral salts from the soil through the root hairs by the process of osmosis. Only a small percentage of this water is used by the plant. The rest gets evaporated from the surface of leaves. This evaporation of water from the plant is called transpiration. Medium-sized, well-watered potted plant. Cup, place an empty polythene bag B with its mouth tied.
Okay, this is another practical that you can do. I think the same practical is there in the book. Let's refer to the book. We have in the same practicals. No. Right. Okay. So this practical is important. I thought that is there. That was there, but not sure whether in the grade 8 book. Yes, you can test this. You can test the transpiration. How? You can test the transpiration by doing small practical using a small plant. Maybe you can use a potted plant, or you can even use the outdoor plant. That doesn't matter. So to test that, what you have to do is you use a polythene bag. Use a polythene bag or covered bag, and then you have to properly cover that using the particular bag. So better if you can seal the stem side, right? When you're covering, so put the leaves inside the bag and just cover from the stem. You can put a rubber band without damaging the stem. Then keep it for some time. So maybe you can observe this under different environmental conditions. You can observe this in a wet day, rainy day. You can observe this during night time, right? During night time you can observe. During the daytime, when sunlight is present, you can observe this. So during a windy day, so you can use same amount of time, right? can use same amount of time and experience. Then check the bag after some time, maybe 10 minutes or 15 minutes. After that, you can check the bag. And you will see this evaporated water will again become water drops. So what is that? So your gas will become liquid. What is the term we are using for that? When gas become liquid?
Condensation.
Condensation. So that is, so Gani Bhavane, condensation. So you can see condensed water in the bag. So just try to measure the amount of condensation of the water in those 4 status, maybe sunny day, during night time, during a rainy day, and during a windy day. Just the humidity will not be able to measure without a humidity sensor properly, but you can use other 4 conditions easily. You know what is sunny day, what is rainy day, a night and day times. You can observe these different and also see the condensed amount of water after each. So keep it for a certain measurable amount of time, right? Maybe, so it's okay to keep it even 1 hour. So, but don't keep it for days because the conditions are changing. So try to make the conditions stable, and or you can use this indoor plant. You can indoor potted plant and change the conditions. That is another thing. You can use indoor potted plant and change the condition. You can turn on light, turn off light. You maybe use some windy air, and maybe you can try these things and get the results in the controlled environment. Okay, that practical, please do this along and try to measure the results, and if possible, please send me the results. So what is the amount of condensed water that you got during that time? The condensation, you have to wait, right? Because evaporated the air will not condense immediately. You have to wait for some time until it condenses. Right. Okay. So the other one that you said is we call photosynthesis is not listed here, but we learned in the different chapters. Even early, we have learned that the photosynthesis is there in these greeny plants. So that is very important. It can produce its own food using this photosynthesis process. And so the different environment. So the plants are adapted to the minimize transpiration, especially when plant is there in windy environment. If plant is there in some dry environment, so these plants are adapted to minimize the shape of the leaf will be different. So some are having thick and waxy skin, right? Basically, temple tree, right? You can see that temple tree, pathok like cactus. You can see that. So thicky and waxy to protect water inside the leaf. And some are even having these, you can see, so it's adapted like this. So thin leaves is another, or reduced number of leaves. Some leaves are falling down sometimes, right? So these leaves, number of leaves are reducing. So these are some adaptations happen in the different environment to protect water inside. Because actually the amount of water that the plant use is, it's not using 100% water. So even though it absorbs a lot of water from the ground using their stems, their root system, it uses very less amount of water for its tasks. So other will anyway transpirate. It had to move. But the thing is, so depend on the environment, you have the plant need to be adapted, or plant need to be adjusted according to the environment. Otherwise, it will dry and die. right? It will dry and die. So it will become dry and then it will die because the required amount of water is not there in the plant. And so aloe vera, you can see, it's a great mechanism of protecting water, and it can adapt it to some what do you call extreme environments by doing this. Okay, so that is about leaves. I think we have discussed about a lot of features of leaves, the tip and the arrangement. So you have to do one activity related to an arrangement. Next day I'll expect in that. And another practical that I ask you to try out, that is to check the transpiration. And so please try to do that as well. And these you can see the environment related adaptation of these leaves based on the environment to protect the amount of water which can be lost due to transpiration. So these are some things that we have learned about. And so one very important thing of Akapana or begonia is it can reproduce. It can reproduce. That means the small baby plants can draw from leaves. Wonderful, right? So normally, so you know that flowering plant will grow from seeds or this flowering mechanism, or sometimes if it is non-flowering or some even non-flowering or flowering plant, both they are. So it can grow from the stem or branches. That is normal, no? But so this begonia, Akapana-like plants can grow from the leaves. So it can grow from the leaves, right? That is wonderful. So you can see this here, small stem began from the leaf. Leaf can reproduce. So, but that is asexual reproduction, right? That is not the sexual reproduction. It is asexual reproduction. That is not happening due to so normally in the flowering plants, so there is a nice way of reproducing. So that is a sexual reproduction. But here it uses asexual reproduction. That means no need to have there are two parties, two variants, female components and the male components together forms the baby or the small. But here the thing is small version, but here it's not. So it's using its own cells to produce new plant. So that is there with these plants, right? So that is a nice feature. Here actually, so there is experiment related to that as well. So this also can be observed. So can you find these things? That is the problem. So if you can find this, so this is rare. Earlier days, I used to find these plants.
I can find, sir.
You can find.
Yes, sir.
Yes, then good. So then just give a try. So this, so if you can, so do you have a YouTube channel? Do you have a YouTube channel or no, Sunny? No.
No, sir.
Okay. So shall we do something like this? This is something interesting. You are coming to IT class as well, no? So try to. So it's not deep. It's not difficult, right? If you have a Gmail, you can create a YouTube channel, but you have to get parental support because you're still small. And if you create a YouTube channel without parental support, the thing is it will be banned or it will be removed from YouTube. So you have to get maybe involvement your parent, maybe your mother, father. If he or she is present in a frame or his or her voice is there in the frame, that is enough, right? So rather than voice, try to make them present somewhere in the video. So then that will be okay, right? So what you can do is, why I'm asking you to try this, because you can express these things and you can share this knowledge with others. That is one thing, and it will be interesting. So there is a feature called time lapsing. Have you heard of that?
Yes, sir.
Yes. You have to take photos. You have to take photos of the plant from the same angle. Here, actually, you have to observe this for 3-4 days now. maybe each hour you can take a photo daytime, but nighttime, so it's difficult. But anyway, during daytime, you can give a try. Try to get a photo each hour from the same angle, same light condition if possible. So try to get a photo. So then collect these photos and you can play these photos as a sequence. So that will become video. Right? It will be nice observation if you can do like this. So you can prepare a video. This is actually, so I'm not sure whether it will be available in YouTube since it is, so Akapana is not a word, right? I'm not sure, right? But you can add it. No, it's not there. No, it's not there. So let's remove this one. No time lapse are there. So here, so you can see there is yeah, that is the advantage. If no such videos, if you can upload that and share with your friends, it will be interesting because they can also, so because then when they see the video, they don't want to redo the practical and they can understand what will happen. So small, like small work to do, you have to take photos and merge them to create the video. I'll teach you how to do that in the IT class, or maybe if you need, you can just ask me for a help and I'll do that. I'll tell you how to do that. Even you can use Microsoft PowerPoint to do that. So that is the easiest way of doing. Anyway, so try to do this practical. So try to observe this for 3-4 days and take pictures. Maybe each hour, if you can take pictures, it's better. So then we can merge them and create a time lapse in video.
Okay, sir.
Okay, so then, right, next is like diversity and functions of the plant stems. That I'll keep for the next day. Leaves we have discussed, then the stem and root. Root also we have to discuss a lot because some roots are actually some roots are prop roots, still roots, climbing roots, likewise different root systems are there. So we need to discuss a lot of things about this root system too. And stem, we don't have to discuss much. Stem, we can finish next day. And week after next day, we can discuss about the root system. Okay, then I'll stop for today. Next day, we'll be discussing the next part. Good night.
Good night, sir. Thank you, sir.